Okay, so let's go on and go through problem number 8. Once again, I'm going to encourage you to pause this video at this point, try some of these problems on your own. Like I said before, I do have another worksheet for you, so don't be feeling like, hey, you know what? I don't feel like that I'll have enough problems over here. I need to do this on my own. Trust me, I have enough for you to be doing on your own. All right, so with that said, let's go through this problem, or like I said before, pause the video, try it out on your own. But let's go through this problem right now. With an average acceleration of 0.5 meters per second squared, how far does the cyclist travel if starting from rest and reaches 7 meters per second, which is 16 miles an hour? Okay, so let's read this again. With an average acceleration of this, how far does a cyclist travel if starting from rest? Okay, so we have our cyclist and starting from rest and he's going to reach this certain velocity here. Okay, so, all right, I think that we have enough here. What are we going to say that the initial position is of the cyclist? Okay, so it's 0 meters. What is this first piece of information telling us? With an average acceleration of 0.5 meters per second squared. Well, it's telling us that that's the average acceleration, and the other key clue is telling us that it's meters per second squared. So we're being given here the acceleration. Okay. How far will the cyclist travel? So what is that asking us? If starting from rest, what is starting from us telling us? Hopefully by now you're saying, hey, you know what? He's not going fast at all, or he's just got no speed. He's at rest. We know that the initial velocity is 0. And he's going to reach 7 meters per second. What is the meters per second telling us? Well, by now, hopefully you're saying that's the velocity, and that is specifically our final velocity. Oh, this is a little squeezed in here. I apologize about that. But we have all of our information that we need. We have our final velocity that we're going to be looking for our final velocity, our final position. And we have a variable that we don't care about. It doesn't mention anything at all about time. It doesn't ask us for time. That's the variable that we don't care about. And that's the variable that we're going to be looking for when trying to select our kinematic equation. So, once again, are we given any information on our average velocities? No, right? So therefore, we know that we're not going to be using formulas 1 or 2. We know we're going to be using formulas either 3, 4, 5, or 6. So the variable that we don't care about is delta t, so we're just going to be looking for delta t right now. Oh, we got delta t right there. Don't care about this one. Not going to be using that formula. What about this over here? Oh, we have delta t right there, so we're not going to be using this formula. Over here, have delta t right there, and delta t right there. We're definitely not going to be using this formula. And do we have delta t in here? No. Okay, so that's going to be our indication that this is the formula that we're going to be using. So let's use that. I'm just going to erase our pretty little drawing. And we're just going to be using our 6th formula. Okay, so let's just do our substitutions, and we'll go from there. Okay, so 0 squared, 0 times 0 is equal to 0, so we don't care about that. A subtraction of 0, that's not going to provide any value whatsoever. So we have 7 squared, which is equal to 49, which is 7 times 7, right? And then we have this positive 2 times 0.5, so that's just equal to 1, right? And so we're just left with xf is equal to 49. And that's our answer. Okay, well, that's simple enough, right?